So because this is our first video, let me start off by saying that no, you do not have to record every single note that you see in the slides. What's more important is that you understand everything. If it helps you, you should copy everything. No matter what, whether you copy the notes or not, you are still responsible for everything that is taught in the slides. So keep that in mind as well. Make sure you do the practice. The most important thing is that you pause the video as you go along to make sure that you understand, because I might have to go fast in some spots. All right, so the first thing we're going to do is compare quantitative to qualitative. Quantitative data is a way that you can describe your data, and this is data driven by numbers and the amount of something. I remember numbers because there's an N in quantitative compared to qualitative, which we'll talk about later. So here in the example, in the picture on the right, there are 3 candles. The shortest one is a certain height and the tallest one is a certain height. All those numbers are quantitative data. Now, if we compare that to qualitative, that means that it's data driven by the characteristics and what you can observe either by your eye or by your senses, which include your sight. So here, the 3 candles are red. The one in the middle is medium height. Things like that don't include any numbers is qualitative. And here I remember that there's a word L in qualitative, and for me, L means letters. So that means words. All right, so then we go into scientific notation. Hopefully this is already review of what you already do know, but this is a way for us to handle very large or very small numbers. The sun's diameter, so going from one side of the sun to the other side of the sun, is 1,392,000 kilometers. Well, it's a big number, so let's put it in scientific notation. The way that we do that is by following the steps on this slide. So we're going to find the decimal in the number. In this number right here, for the sun's diameter, the decimal is right behind the 0. It's not written there because you don't technically have to write it there. So then you move the decimal so that's between the first and second real number that's not a 0. So I'm going to move it, move until it is between the 1 and the 3. So then here I get 1.392. I drop the zeros at the end because they're no longer important. I count how many times I move the decimal, and this number is my power. So I move the decimal over 6 places. That is my power. Now you're always going to write times 10. The exponent of that power is going to be how many spaces you moved in. And then let's say that we have a different example where we've got the nucleus of an atom, and just for you to think about it, the nucleus compared to the atom itself is as if you had a blueberry as your nucleus and it's sitting in the middle of a football field. Very, very small. You're not going to be able to find the nucleus if that's the case. So then here, this is a very small number. So we're still going to follow the same steps. We're going to put that decimal in between the first and second real number that's not a 0. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 spaces. And once I've reached 15 spaces, I have 1.6. The zeros are at the beginning, so I'm going to get rid of all of these zeros. So when I write my answer, it's 1.6 times 10. You are always going to write the times 10 part in scientific notation, and then to the negative 15. 15 because we moved it over that many spaces, negative because this number is smaller than 1, which takes me into the next slide. So if the number is bigger than 1, then my power is positive. If my number is less than 1, my power is negative. This is review, so we went a little fast. Do these 2 practice, pause the video. If you think you've got it right, then keep watching to get your answer. First one, you should have gotten that answer. You take your decimal place. Right here at the end, you have to move it over 1, 2, 3, 4, 5, 6, 7, 8 times to get 2.98. Vice versa, we've got a very small number that's smaller than 1. So my answer for the next one is going to be to the negative 4 power. Here I take the decimal, I move it over 1, 2, 3, 4 spaces, 1.043 kilograms. All right, if you feel like you need more practice, you should go to this link right here. There are multiple choice answers. You pick the right answer, you check your answers, and you get the practice that you need. Now, the important part is that because we deal with such big and such small numbers, there's a specific way I want you to type it into your calculator. I don't want you to type out multiply 10 carat like that in your calculator. It'll likely get you the wrong answer, or it'll be so long and drawn out that there are other parts to the problem that you can make a mistake on. So on most calculators, you should find a button that says EE capital or just a capital E. Here's my calculator, and I'm going to find it on my calculator by looking at the comma button right above the 7, and there's EE right here. The way I get to it is by hitting second E. So for this first example, 6.23, instead of writing out the times 10 part right here, I'm going to replace it with the E. So I hit second E, and then my exponent is -5, so then I type that. Divided by, I don't need any parentheses for these because if you use the E correctly, you shouldn't need parentheses. Divided by 4.28. Again, I'm not going to write out the times 10 part. I'm going to type in E instead, -9. So then your answer, we're just going to round our answer, 14,556.07. We're good with that. Let's do the next one. Still using the E button. So I've got 4.82. Again, I don't write out the times 10 carat part of my calculator because I'm going to use the E button right here. To the 8 multiplied by 1.92. Again, don't type out the times 10 part. E7, 7's my exponent, and here's my answer, 9.2544, E15. So this E, remember, means times 10. When you write your answer down on your paper, you cannot write E15. You have to write out 9.2544 times 10 to the 15. It is incorrect if you just write E. It is also incorrect if you just write 9.2544. That's an extremely small number compared to the actual correct answer. All right, last thing is that you need to know the system of units. This is how we're going to record units in this class. If we're talking about the length of something, it'll be in the metric system. So meters, centimeters if it's very small, kilometer if it's very long. The mass of something will be in kilograms if it's big or heavy. If it's something smaller, we're going to use G for grams instead. Time is going to be in seconds. You know what seconds are. Temperature is something called Kelvin. So the United States uses Fahrenheit. Everywhere else uses Celsius. But in science, we're going to use Kelvin, and you'll learn what that means later. The amount of a substance here, in comparison to this, let's think about eggs. If you have 12 eggs, that's 1 dozen. You can describe the amount of a substance in chemistry in regards to mole. That's just how much there are. And this is also a concept that we will learn later. So just keep in mind the 3 main things you need to know right now is the length, the mass, and the time. Those are the units that we have to use. We can't use feet or yards for length. We can't use pounds or ounces for mass. All right, hope you understand the video.